This is not a drill. This is an official emergency broadcast. A USGS red alert has been issued. The United States Geological Survey is activating its highest level of alert for the Pacific Northwest. The states of Washington and Oregon are now under an immediate threat advisory. The ground beneath millions is under scrutiny. Every tremor, every shift, is being meticulously monitored. Scientists have detected something unprecedented. Their instruments are registering anomalies never before observed in this region. The alert means a volcanic event could be imminent. A major eruption is a distinct possibility, or already underway. The initial stages of a significant geological event may already be in progress, but this time, it's not just about one volcano. The threat extends beyond a single peak or localized area. Advanced satellite technology, utilizing cutting-edge sensors and imaging techniques, has revealed a shocking discovery. Data analysis points to a previously unknown interconnectedness. Deep beneath the Cascade Range, hidden from view in Washington and Oregon, spanning state lines and geological boundaries, lies a potential network. A complex web of geological connections may exist far below the surface. This isn't just about Mount Rainier with its looming presence and potential for catastrophic eruption, Mount St. Helens, still recovering from its devastating past, or Mount Hood, a popular destination that also holds significant volcanic risk, acting up individually. The concern is no longer limited to isolated incidents. It's about a hidden system, a subterranean network of magma and geological forces that could change everything we thought we knew. This discovery challenges our understanding of volcanic activity in the region. These legendary volcanoes, the iconic peaks that define the Pacific Northwest, Rainier, St. Helens, Hood, are not isolated. They are potentially part of a larger, more complex geological structure. They may be linked by underground pathways, hidden channels that connect these seemingly separate entities. Imagine tunnels filled with molten rock, rivers of magma flowing beneath the surface, connecting these giants, a vast interconnected system of volcanic activity. For centuries, these connections went undetected. Traditional geological models failed to account for this potential link. Now, scientists are forced to ask urgent questions about the nature of this network. What does this mean for the millions living nearby? How will this new understanding impact safety and preparedness? The implications are enormous. The scale of the potential threat is far greater than previously imagined. If these volcanoes are truly interconnected, if they share a common magma source and subterranean pathways, the threat is on a whole new level. The potential for widespread devastation is significantly increased. The core fear, the primary concern driving this urgent alert, that a disturbance in one, a minor tremor, or a buildup of pressure in a single volcano could trigger activity in another. A domino effect setting off a chain reaction across the entire Cascade Range. This revelation demands urgent answers. Immediate and comprehensive research is essential. What does this mean for the future of the Pacific Northwest? How will this change the landscape and the lives of those who call it home? We need answers. We need to understand the full extent of this interconnected system, and we need them now. Time is of the essence, and the clock is ticking. The stakes have never been higher. The future of the Pacific Northwest hangs in the balance. What exactly is magma? It's superheated liquid rock under immense pressure, fueling volcanic eruptions. Now let's talk about magma tunnels, nature's underground highways. These aren't just cracks, they're complex systems formed over millennia. They can stretch for miles, connecting magma chambers or linking chambers to the surface. If new magma enters, it can travel, like water through pipes. The discovery of tunnels linking major volcanoes is profound. It suggests a shared plumbing system. If one part activates, could it push magma or pressure into another? Could a disturbance in one volcano trigger another? That's the billion-dollar question. This isn't just about individual volcanoes anymore. It's about a potentially interconnected volcanic province, a network that could behave in unexpected, dangerous ways. The implications for hazard assessment are staggering. Scientists are racing to understand what this means. Let's pinpoint these giants on the map. We're going to take a closer look at the specific locations of these potentially dangerous volcanoes within the Pacific Northwest. Understanding their precise positions is crucial for assessing the risks they pose to nearby communities and infrastructure. Mount Rainier, a majestic snow-capped peak that dominates the horizon. Located in Washington state, it stands approximately 59 miles southeast of the bustling city of Seattle. This proximity means that a significant portion of the population lives within range of its potential hazards. Towering over 14,400 feet tall, Mount Rainier is not just a mountain, it's an active stratovolcano, a type known for its explosive potential. Its imposing presence is a constant reminder of the geological forces at play beneath the surface. Millions of people reside within its potential hazard zones, including areas susceptible to lahars, pyroclastic flows, and ashfall. The potential impact on these communities is a serious concern. Next, Mount St. Helens, a stark reminder of nature's power. Also situated in Washington, it lies approximately 96 miles south of Seattle and about 50 miles northeast of Portland, Oregon. This places it in a region with significant population centers on either side. Its catastrophic eruption in 1980 served as a dramatic demonstration of the destructive forces volcanoes can unleash. The eruption plume reached incredible heights, and the surrounding landscape was utterly devastated. The 1980 eruption dramatically changed the landscape and profoundly altered our understanding of volcanic risk and the potential for widespread devastation. It was a wake-up call for volcanologists and emergency management officials alike. And finally, Mount Hood, a prominent feature of the Oregon skyline. As Oregon's highest peak, it's located about 50 miles east-southeast of Portland, making it a popular destination for recreation and a significant part of the region's identity. Reaching an elevation of 11,249 feet, Mount Hood is a formidable presence in the Cascade Range. All three of these volcanoes are classified as active, meaning they have the potential to erupt again. They are closely monitored by scientists using a variety of instruments, and they are surrounded by densely populated areas, increasing the stakes. The Interstate 5 corridor, a major transportation artery, runs nearby, connecting major cities like Seattle and Portland, placing countless travelers within potential impact zones. These volcanoes are not remote wilderness features. They're integral parts of the landscape and daily life for millions of people living in the Pacific Northwest. This new discovery, therefore, directly impacts these communities, raising important questions about safety and preparedness. The proximity of people, homes, businesses, and critical infrastructure to these potentially dangerous giants makes understanding and mitigating the threat an urgent priority. These are not just distant scenic peaks, they're at the very heart of the Pacific Northwest's identity and its future. The stakes are deeply personal for everyone living in their shadows, working in their foothills, and traveling through their valleys. This is precisely why the Red Alert matters so much. It's a call to action. It's not just a scientific issue confined to laboratories and research papers, it's a potential community crisis that demands attention and action. The time to pay attention, to learn, and to prepare is now, before it's too late. These volcanoes demand our respect and unwavering vigilance. We must remain aware of the risks they pose. The new findings have fundamentally changed the risk equation, requiring a reassessment of our preparedness strategies. The safety and well-being of the entire region depends on a thorough understanding of what's happening deep below the surface. The world is watching with bated breath. The Pacific Northwest is on edge, awaiting further developments, and the next move, whether by nature or by us, could be absolutely critical in shaping the future of this region. These majestic peaks piercing the sky are more than just scenic mountains. They hold a secret, a powerful force simmering beneath the surface. They're active volcanoes, restless giants that form a crucial segment of the Pacific Ring of Fire, a zone known for its intense seismic and volcanic activity. This ring encircles the Pacific Ocean, marking the boundaries of several tectonic plates. The Cascades, this chain of volcanoes, are relatively young, geologically speaking. Their formation is a testament to the ongoing processes shaping our planet, and they are very much alive, constantly emitting steam and gases, a clear indication of the molten rock churning within. These are not relics of the past. They are active participants in the Earth's dynamic present. Among them, Mount Rainier is considered one of the most dangerous volcanoes in the U.S., a looming threat to the surrounding communities. Its sheer size and proximity to major population centers make it a primary concern. Its extensive ice cap, a beautiful but perilous feature, could trigger massive mud flows, lahars, if it erupts. The heat from an eruption would rapidly melt the ice, creating a torrent of mud and debris. These lahars, dense and destructive, could reach populated areas miles away, burying everything in their path. The potential for widespread devastation is very real. Mount St. Helens' cataclysmic 1980 eruption dramatically showed the explosive power of these volcanoes, a stark reminder of the forces at play beneath our feet. The eruption was a watershed moment in volcanology, providing invaluable data about volcanic processes. It flattened forests for miles around, and sent ash across states, disrupting daily life and impacting air quality. The ash cloud circled the globe, a testament to the eruption's magnitude, and changed the landscape forever, leaving behind a stark crater where a majestic peak once stood. The recovery of the surrounding ecosystem is a slow but fascinating process. Mount Hood, while perhaps less infamous than its southern neighbor, has erupted multiple times in the last 1,500 years, a history of activity that demands our attention. It remains an active volcano, capable of producing future eruptions. Future eruptions from any of these volcanoes could disrupt air travel on a global scale, threaten communities with pyroclastic flows, ashfall, and lahars, and send mud flows downstream, impacting water resources and infrastructure. Each volcano is a major hazard on its own, a complex system with the potential for significant destruction. The idea of them being interconnected, sharing a common magma source, multiplies the risk exponentially, creating a scenario that demands careful consideration and planning. A disturbance in one could affect the others, potentially triggering a chain reaction of eruptions. The entire Pacific Northwest region could be at risk, not just isolated areas near individual volcanoes. The interconnectedness of the system means that the impact could be widespread and devastating. This is why scientists are so concerned, dedicating their lives to understanding these complex systems and mitigating the risks. The stakes are higher than ever, demanding a proactive approach to monitoring and preparedness. The red alert is not just a warning, it's a call to action, urging us to take the necessary steps to protect ourselves and our communities. The Pacific Northwest must be ready, with comprehensive evacuation plans and robust emergency response systems in place. The world is watching how we respond, learning from our efforts to understand and mitigate volcanic risk. The next eruption could be unlike anything we've seen in recorded history, a truly unprecedented event. Preparedness is no longer optional. It is an absolute necessity for the communities living in the shadow of these magnificent yet dangerous volcanoes. This discovery wasn't made with shovels, it took cutting-edge satellites. Instruments like INSAR and Deep Earth Tomography detected subtle ground movements and heat patterns. Scientists noticed coordinated anomalies between volcanoes, signals that didn't fit old models. Months of satellite data revealed possible underground pathways. These channels weren't on any map, they were hidden deep below. The implications? If these volcanoes share a plumbing system, an eruption at one could impact the others. Emergency plans may need urgent revision. Our understanding of regional volcanic risk has changed overnight. The scale of a potential event is now far larger. This is a game changer for hazard preparedness. USGS experts are cautious but deeply concerned. This is uncharted territory for volcanology. One official called the findings frankly terrifying if proven true. The red alert reflects both caution and urgency. Dr. Eris Thorne, a leading volcanologist, says, "If these tunnels link Rainier, St. Helens and Hood, it's a paradigm shift." The scientific debate is intense. Is this one massive system or localized linkages? More sensors, more data, and rapid research are needed. The pressure is immense. Millions could be affected. This isn't about panic. It's about responsible science and risk management. The Earth is sending signals. We must listen and act quickly. The safety of the region depends on it. What if these volcanoes are truly connected? Imagine Mount St. Helens erupts. Could it trigger Rainier or Hood through these tunnels? This is the nightmare scenario. Linked eruptions, a domino effect. Multiple volcanoes erupting could devastate the entire region. Ashfall, evacuations, and chaos on a massive scale. Emergency services would be overwhelmed. Scientists are running models, hoping this level of connectivity isn't real. But they must prepare for the worst. Ignoring the risk would be irresponsible. The stakes are too high for complacency. The Pacific Northwest must be ready for any possibility. History offers stark warnings. Mount St. Helens, 1980, sudden violent 57 lives lost, ash across states. Krakatoa, 1883, global impact, tsunamis, tens of thousands dead. Vesuvius, 79 AD, Pompeii buried, civilization erased. Volcanoes operate on their own schedule, human plans mean nothing to them. Their power dwarfs anything we can imagine. We forget this at our peril. But we also learn from disaster. Volcanology has advanced better monitoring, better plans. Yet nature always surprises us. This new discovery is a wake-up call. There's always more to learn. Vigilance is essential. The past teaches us to respect these forces. The future depends on our readiness. This news is alarming, but panic helps no one. Information is power. Understanding risk is the first step to safety. Stay informed through official sources like the USGS and local agencies. Avoid rumors, trust the experts. Have a plan. Emergency kit evacuation routes. Family discussions. Simple steps can save lives. Preparedness brings peace of mind. This discovery is a wake-up call to invest in science and monitoring. Communities must be ready. The Earth has spoken, we must listen and act. Stay safe, stay informed. The future of the Pacific Northwest depends on it.